We've now had a little bit of time to learn and think about the soil production function. And so think about how thickness of the soil column might evolve through time. So for example, we have this exponential decline model right here. And in the exponential decline model, we're going to have maximum soil production rates when there's no soil cover. And then as the soil cover increases, the soil production rate is going to go down. On the other hand, we have the Hump model, where soil production rates start out low. They go to a maximum right here at some intermediate depth, and then eventually also go down as soil depth increases. And right now this is the rate, right? And so if we're thinking about rates, we're thinking about a time derivative. But what we actually observe on the Earth's surface is not the time derivative, right? We exist in time, and so therefore we actually observe the state, which is how much soil is there right now and how deep is it right now. So I want to really quickly go through with you just a quick thought experiment. I'm just going to zoom out a little bit so maybe we can see both of these at once. And so let's think about how soil thickness is going to change with time following this hump function. And so at the very starting time, we're going to start out with 0 soil thickness. So we're going to pretend that we're starting out with a condition in which we have, and I'm going to draw a little cartoon down here for you for this thought experiment. We're going to start out with some sort of, bare, bumpy bedrock. And the other thing we're going to do is assume it's approximately flat. And so that means that there is no material movement in and no material movement out. In other words, we're dealing with just weathering and soil production. Yeah, no material in, no material out. So what we do is we look up here and we start out with nothing, and then that nothing grows a little bit. And as that nothing grows, we go from this soil production rate to a little bit higher of a soil production rate, and so we start to grow faster, and so on and so forth. And so actually there's an accelerating growth of soil thickness through here, through this point. So if we kind of do a little dashed line going down through there. And what that means is that it's kind of hard to create an initial crust of soil on a bare boulder where there's no material there to actually cause there to be some water trapped or chemical reactions or any kind of decay. And so you can think about this in the same way as you think about, like, if you have a back deck or a roof or something, you want to get the leaves off because you want to be able to remove anything that would be able to trap in moisture and cause decay. And if you live in an apartment or condominium, let's just think about, washing the dishes, right? You want to have clean dishes, nothing on them. And if you have like a little layer of scuzz, that can really lead to some problems down the road. So over here, we're going to look at the fact that now this soil thickness, is going to be increasing with time still, but at a decreasing rate. So we're going to go from here and go up to this and kind of continue on like so, like so, like so. And we're going to keep on increasing how much soil we have, but at a decreasing rate. And so this is what this curve is going to be like. And this is basically just, or is exactly just, the integral of this whole curve right there, dt. And so this is what you might expect. And so let's think about a couple landscapes. And so if we think about something like if you've been to northern Minnesota, if you've been to a recently deglaciated area in the Rockies, there's not much soil to really a thin carapace. But then if you've been to some place that has had a little bit longer, it actually very rapidly will convert from being this very thin layer right here to this quite thick mature layer of soil, because it goes through this rapid acceleration of soil production, going through this hump right here and then into this tail. And so we end up seeing, some soils that are very thin, some soils that are very thick, and some that are in this transitional area.